Welcome to version 1 of our scriptable text adventure game engine. The S engine provides the user with the ability to create a world with areas and transitions. Along with that, the user can define specific descriptions for each part of the world that they create, such as connections, areas, players, and the world itself. Once finished creating the world, the user may navigate through it and view specific entities which display their names and descriptions.
Initially, we never got rid of our architectural spike code, but this presented us with many problems when attempting to add more complex features, and ultimately reminded us that restarting after an architectural spike is the best approach. After adjusting, we focused on more basic goals such as providing the ability to create a world, traversing the world, and viewing the world as you explore it. Focusing on these basics allows us to prepare for more complex features later on. We made some process adjustments this cycle with regards to Git and Google Drive. During the cycle, we accidentally deleted code after hours of work because we were too lenient when committing to the master branch. So we now will be more careful by using development branches to control the merging of different features. Google Drive has been our central location for all cycle content. When we're trying to bring everything together in the end, we quickly realized that our cycle content was a bit scattered. To address this problem, we created a folder for each cycle with their own administrative digest and software development folders, where we will update their contents throughout the cycle.
We were able to hit all of our goals for this cycle even after ditching our architectural spike code. We have implemented the basics for creating, traversing, and viewing the world. Creation of the world allows the user to initialize a world and the areas in the world with their own names and descriptions. The traversal feature includes the ability for the user to create transitions. These will connect areas together and also provide the ability to define the constraints that restrict or allow user movement. The feature for viewing the world is in the most basic state. Currently, it allows the user to look at the area they are in, which displays the names and descriptions of the area and its transitions and where they lead.
We developed a plan that required designing features in sequential order: creation, then traversal, then viewing. This plan allowed us to coordinate our designs, which led to easier implementation of the features as a whole. In order to be able to properly traverse a world, the user must first be able to create a world. The design for creating the world made for easy integration of traversal logic. Once the user was able to create a world and move around inside of it, the logic for viewing the world became a trivial task that we were able to easily implement over the top first two features, creation and traversal.
John here. I will now be taking you through the final design and the demo.
So here's our final working design for our engine. You have an author. They have access to the world through a parser. So the author will create the world with methods from the world class, and once they're done making the world, they'll pass the world to the parser, and the parser will essentially play the world. You can see here that these all have their own properties. All of them have name and description, and then areas have arrays of transitions, and transitions have directions that they lead to if they're passable, where they are, where they lead to, all those things. A player has a name and a description, where they exist, and the area, has an array of area objects because the world is composed of areas. So now I'll take you to a more technical design document where you can feel free to pause the video if you'd like to read some of it. So here we have our technical design document. I'll just scroll through this shortly so that you can take a look and pause the video if you'd like to read anything. It contains anything from the properties to the logic to the pseudocode of all of the features that we've implemented so far. This document really helped us to stay on the same page so that when we were all implementing our own individual solutions for a feature, we could avoid roadblocks and connect all of the moving pieces together in such a way that it would be easy. So now we can head over to the demo and take a look at how all this works. So on the left here we have the author file. This is where the author defines the world with a Python script. And on the right we have the world file, which contains all the objects and methods that the parser and the author need to have access to in order to create and play the world. So to start off, we make a player, give it a name and a description. Then we make a world, we pass it a name, a greeting to say to the player when they enter it, and the player object to actually exist in the world. So then we create some areas, make a quarry, give it a placeholder description just so I can show you how once an area is made in the world, you can still manipulate its properties based off of how we allow you to. Right here you can set the description. There are many rocks around here, so that will override placeholder description. And we make some woods, we make a cavern, give them name and descriptions, and then once we make these areas, we need ways to connect them, so there are transitions. For example, we make a path in the west of the quarry that leads to the north of the woods. It's a two-way transition, so you can go back and forth, and this is its description. It's covered with giant boulders. This example right here shows how transitions return tuples. This is very useful because you can directly manipulate either side of the transition. If you go in one way and come out the other, those could be totally two different areas, and it could look completely different. So down here we are actually defining specific things about those specific transitions. So where you go in the cavern, if you're successful, it will display this message. Where you go out of the cavern, if you fail, it displays this message. And you will fail because it's defined as a one-way transition. And then we did the same thing with the waterfall. And we also changed the description of out cavern, because if you look into a cavern, it's going to look different than if you went inside of the cavern into the cave and looked out. Those are two completely different descriptions that should be displayed. So we allow that. So let's take a look at how this works. Okay, so we're in the quarry. Look. Alright, if I try to use the waterfall, I can't do that. It's a one-way transition, and it leads from the cave to the quarry, so you can't go back to the cave. It's a little confusing because we started out here. You would think you're going into the waterfall from the quarry, but that's not how it's defined. So, looks like we have to use a path. Alright, we're in the woods. Take a look. Oh, just to show you, we can look at ourselves. Who am I? I'm Johnny, a young man. Alright, Johnny, let's go down the path. No, let's use the cavern. Oh, and I'll show you. You can just type go east instead of use cavern, because the cavern leads east. So if I type go west, there's nothing that leads west, but since the cavern leads east, we can type go east. Alright, so cavern on success. Slide down it, can't get back out. We'll take a look. The out cavern description is displayed. The light is beaming in from above, because that's probably what it would look like if you slipped down a narrow cavern and tried to look back out. So I guess we're going to have to use the waterfall. And waterfall on success is displayed. You wake up gasping for air, you're back in the quarry. So we're right back to where we started. That's all the functionality we have now. Thank you for watching.